So let us now solve some problems of simple harmonic motion. The first group of problems I have modeled is the problems related to reference circle. And this group of problems can be easily solved if you adopt the reference circle approach. For example, look at these two problems. What is the time taken to go from mean position to half of the amplitude if an object is undergoing simple harmonic motion? Second is, what time is taken by the body to travel from the extreme position to the middle of the amplitude, A to A by T. So first you can see is 0 to A by 2, and second the question asked is A to A by 2. Now how do you solve such problems? The first thing you notice is what is the time taken to go from mean position to half of the amplitude. This is the mean position and this is half of the amplitude. So as the body is going like this, what is the time taken from say A to B? That is the question. Now you know that in a simple harmonic motion, the total time period is T. And in the total time period, the body goes from A to C, then C to A to E, E to A. That completes the cycle. So from the mean position to extreme position is 1/4 of the cycle. So I can tell that from A to C, time taken is T by 4, where T is the complete cycle. So intuitively you think that if the body takes T by 4 time, that is 1/4 of the cycle time, to go from A to the extreme position C, this is the extreme position, that is the full amplitude, then A to B will be half of that. Naturally half the distance, half the time. So if it is T by 4, this will be T by 8. Look at this carefully. You see the motion of simple harmonic nature. The velocity is maximum at the mean position. So it's speeding out and then gradually slowing down, reaching a zero velocity at position A or the extreme position. So the velocity is maximum here and becomes zero here. The velocity is all through varying. So it's not a linear relationship. Had it been going with a constant velocity between A to C, half the distance would have consumed half the time. But that is not the case. Each point the velocity is decreasing, reaching here 0 and the mean position is maximum. So the speed is in the second half, you can see is gradually slowing down. The first half is actually more speed. From A to B, the average speed is more than B to C. So A to B is certainly it will take lesser time than B to C. This is without solving the problem also, just knowing the nature of the velocity at different position in a simple harmonic motion cycle, you can tell that. But how to calculate that? You can do this by a conventional method. When you start to think that it can be done like this, we know that there is a displacement x which is equal to A sine omega t. I have taken omega t function because I assume that my reference frame starts here, t is equal to 0, x is equal to 0. So now what do you do? At t is equal to 0, x is 0, I put 0 to A by 2, my question is 0 to A by 2, what is the time? So I put here x is equal to A by 2. When the displacement is A by 2, x becomes A by 2. So at what time it will become? A sine, let us say omega t1, where it is t is equal to 0 and at this position B, it is t is equal to t1. So this is 0 and this is t1. So what do you do? Solve this equation simply. A sine omega t1 is equal to A by 2. This cancel out. This is equal to half. Sine omega t1 is equal to half. That is equal to sine 30 degree, which is cos 60 degree. Or in the terms of radian, this is pi by 6. So what happens is omega t1 is equal to pi by 6. So you put here sine omega t1 is equal to sine pi by 6. Of course, you know that sine this half in the generalized formula is sine pi by 6 plus 2n pi. The sine of any angle after a round of 2 pi, full circle, as many rounds as you can do, will remain same. So here our relevance is pi by 6. So what is T1? T1 is equal to pi by 6 omega. But the total time period T, you know, is 2 pi by omega. So we get at time T1, it will reach A by 2. So we can express this in terms of this. This is equal to 2 pi by omega into 1 by 12. You see, pi by 6 omega, 2 and 6 will give pi by 6 omega. Now replace this by T by 12. So you see, if this is T by 4, this one is T by 12. So how much time is from here to here? You can know that from A by 2, if 0 to A by 2, it is T by 12. A by 2 to A, how much time it will take? A by 2 to A, for example, T by 4 is the total time taken and T by 12 is the first half. So you bring out 12, 3T minus T, that is 3T minus T, 2T by 12 is equal to T by 6. So this is T by 12 and this is T by 6. Together they will add up to how much? T by 12 plus T by 6. This is 12 and T plus 2T, 3T by 12, which is equal to T by 4. That is the complete time cycle. So you see, this is one of the way to solve it. But a much more elegant way to solve it is through reference circle, and that is our topic here. You know, in the reference circle, one thing you notice is the equivalence between simple harmonic motion and reference circle is when the body goes from here to here, here to here, complete time cycle, it is as if a particle is moving through a circle, the reference circle. As it makes one complete round of reference circle, it represents the to and fro motion, one cycle time of the SHM. Remember this, if this is the reference circle, if you put a shadow here, suppose you put a shadow here, then this is going with omega in this direction, so this is theta. Now this is A, the reference circle's radius is A, then this particular thing is A sine theta, which is A sine omega t. So the projection here at this point, when it started from this, it was 0. So t is equal to 0, A sine omega t formula, t is equal to 0, displacement is equal to 0. So as it goes up, this angle theta goes increasing, and as the body comes here, it has come to here, that is 0 to plus A. Then in the return journey, it is back to 0, and here it is minus A. So at any position, this position is attained at 2 points of time. Here in the forward journey, that is going towards the extreme and coming back to the extreme. So one position has two time components. Two time at two different time. One going towards the extreme and returning back towards the main position. The same displacement can be reached. This is one thing in reference circle you should be very careful. Given a position, it can correspond to two type of journey nature. Forward towards the extreme and coming back towards the main position. So how do we solve this particular situation? The 0 to A by 2, look at it. This is our circle, reference circle. Our equation that we have taken is x is equal to A sine omega t. So the vertical shadow, as you throw light here, the P point P. This is A, radius is A. So this is plus A. This is plus A and this is minus A. Remember, if we take A sin omega t as our equation of displacement, then this particular reference circle, the vertical shadow, that is Px, represents the position of the particle in this. So now we know that the particle P has to reach A by 2 from mean position. So our mean position is here. It is going like this with omega. So this is at certain time, the displacement is A by 2. So the displacement is Px is A by 2. What is OP? It is A. So you can see that from here to here is the time that will be taken for the displacement to reach from 0, that is the vertical displacement here, this position corresponds to 0 and this position corresponds to A by 2, in this A by 2. This is A by 2. This is the forward joint. So now what happens? What is this angle? This is A by 2 means half. This angle is sine 30 degree. This is 30 degree. So angle POX is 30 degree is equal to pi by 6. So the particle in the reference circle has turned 30 degree. Now what is the time period taken for full circle, that is whole pi or 360 degree? That is the time period of the circular motion, that is 2 pi by omega. If the particle in the reference circle is going with an angular frequency of omega, the total time taken for the particle on the circle is t, then that is t is equal to 2 pi by omega. So if it is t is equal to 2 pi by omega, for turning 360 degree, how much time will be taken to turn 30 degree? 360 degree angle, that is full, this is one cycle time of SHM. That is the cycle time for the particle to move a complete round in the reference circle, and at the same time the vertical shadow also makes one complete motion. Both consume the same time. Remember, both consume the same time. So if 30 degree, 360 degree takes t, 30 degree will take 1/12 of it. That is t by 12. So 360 degree or 360 degree represents t, therefore 30 degree will represent t by 12. So straight away you avoid all those trigonometric identities and you come here 2 by 12. So if it is 3 by 12 from here to here, and then this here is t by 4, from here to here is 1/4 of the quadrant. So this quadrant from here to here is full is t, then one quadrant is t by 4. This quadrant is t by 4, this quadrant is t by 4, this quadrant is t by 4. So here it is t by 12. You can also find out how much time will be taken for turning this degree. There are two ways. One is you make here as t by, this is t by 12. So here to here, t by 12. What is here to here? If this is 30 degree, what is this? 60 degree. So it will take double the time of this angle. The time taken to turn 30 degree is x. The time taken 60 degree will be 2x. So it is t by 12. Then this will be t by 6. Together they will be t by 4. So it's a very intuitive interface. You see, 30 degree, 60 degree, 30 degree t by 12, 60 degree, double of that. The angle turned is 60. So therefore it will take double the time to cover an arc from here to here that creates an angle of 30 degree at the center. So this is how you can do it easily through reference circle. The other thing is this: what time is taken to travel from A to A by 2? Now let us try directly to do it through the reference circle. So I draw a reference circle like this, and my journey starts here because my equation is A sin omega t. So at t is equal to 0, my x is 0, and the displacement is displacement of SHM particle corresponds to vertical projection. That is, if the particle is P, here it is P1, vertical projection of reference circle particle. So, if the reference circle particle is here, the vertical, this is the vertical shadow, and this is the, if this is P, this is P1, this is 0, this is P. So, this is my assumption of reference circle, and that is A sin omega t. Now, what is this question? The question is A to A by 2. A to A by 2. So this goes like this, omega. So where is A? Where is the body? SHM body reaches the extreme position in amplitude A. See, here it starts from 0, here it reaches. So here is the position A plus. It will come to A by 2. Remember, while going, it has gone to A by 2. So this position. This is the position. Let's say this is P1. What is P1's projection? A by 2. So this is A by 2. So that means this is A by 2. So this is A by 2. This is. So he tells that how much time it will be taken from A to A by 2. That is from this point to this point. That means the angle turned will be this. Don't confuse it with this angle. This angle is P1 to probably this ZX, that is A by 2 to back to extreme position. Interpret this carefully. From A to A by 2, at position, this body turned like this, it reached A at point P. Then it comes back. From here it returns back. In this journey, it is returning back journey. This journey is going up. This journey is going down. This journey is going up. This quadrant and this quadrant. So from A to A by 2. This is A by 2. This is A by 2. So it has to turn this angle. Naturally, this is A by 2A. So this is 30. So this is 60. So what is the answer? How much time? This question is equivalent to asking how much time it will be required for the body to come from P to P1 in the reference circle. That is to turn an angle of 60. 360 degree T, 60 degree, 1/6 of T. So this is T by 6. Answer to here is T by 6. So you see here, this is, you can in fact break this circle into several parts now in terms of half. From here to here, from 0 to A by 2, this, then this, from A to this A by 2, this is A by 2, this is T by 6, T by 6, T by 12, T by 12. This is A to A by 2, T by 6, A by 2 to back to mean position, T by 2, 0, mean position to A by 2, T by 12 and T by 6. So you can break the quadrants of a reference circle into these kind of time segments, T by 12, T by 6, T by 6, T by 12.